Welcome to my project bazaar.com. Let me discuss about the process join PAPR reduction and sidelobe suppression using signal cancellation in NC-OFDM based cognitive radio systems. Due to the transmission of transmitter, the high power to average power ratio and the large spectrum sidelobe power and are two main drawbacks in non-contiguous orthogonal frequency division multiplexing based on cognitive radio systems. In this method, we propose a new signal cancellation method for joint PAPR decrement and sidelobe suppression in NC-OFDM based CR system. The schemes for proposed method is to dynamically increase the part of cancellation points on the secondary user subcarrier and add the minimum signal cancellation symbols on the primary user subcarrier for an accurate cancellation signal for joint PAPR reduction and sidelobe suppression. The further process of SC method to formulate stick faculties on joint PAPR reduction and sidelobe suppression as a quadratically constrained quadratic program QCQP to obtain its optimal signal cancellation signal. We also use the suboptimal signal cancellation method to effectively overcome the QCQP optimization problem within minimum computer difficulty, and the final results show the signal cancellation method and suboptimal signal cancellation method to organize the both characteristics of PAPR reduction and sidelobe suppression. The NC-OFDM based CR system has many advantages that means it has many disadvantages. Hence, it is highly desirable to suppress the spectrum sidelobe as much as possible in the NC-OFDM based CR system. We have to choose the popular modulation technique as orthogonal frequency division multiplexing based CR system. We have to generate the random input OFDM signal as taken as input signal in this model for to reduce the joint PAPR and to suppress the sidelobe in the CR system. Input signal is fed to the QAM in OFDM process of the CR system. Then the modulated signal are sensed and allocated by the CR system. Then the particular signal are processed with FFT and then transferred over the signal. Then the OFDM signal is received at the OFDM system receiver. The PAPR reduction is to be the peak to average power ratio reduction in the modulated input signal using IFFT operation. Peak signal sequence is clipped from the original signal and then calculate the PAPR value between the clipped sequence to original sequence of input signal. From that calculation clears how range of PAPR is increased and the PAPR is to be reduced using signal cancellation technique. Suboptimal signal cancellation method gives significant result at the joint PAPR reduction in the OFDM system and finally calculate the displays minimum mean error rate MMSE from the clipped sequence original signal. Then sidelobe suppression is to be the how to sidelobe is to should be degraded from the modulated sequence of modulated original signal. Inverse fast Fourier transform method is also used for generating random input signals to sidelobe suppression process. Inverse fast Fourier transform method is to be applying suboptimal signal cancellation scheme such as quadratically constrained quadratic program to the modulated input signal, and then to add the several signal cancellation symbols at the primary user and then extend the signal cancellation symbols at the secondary user on the input signal from the easily suppressed sidelobe of the OFDM process. This is MATLAB main window. In that main window, we have to choose many properties to run our basic idea of to run our process. This is the current folder. Whenever you load any files in our MATLAB software, the files should be shown in that window. This is the command window. Whenever we have to run any coding in the program, MATLAB is to be viewed in that execution parts in that command window. This is the workspace. The values and variables are also the functions are shown in that part of the MATLAB window. Then this is the command history. The command history is nothing but the values and variables and functions are handled in that process. Command windows should be showed in that history in this process. Now we have to run our process. Click the final.yum file right click run. Now we have to still running our program. It takes some time to final process of our process. The joint PAPR reduction is sidelobe suppression using signal cancellation method. Our process is finished the running of our process. Joint PAPR reduction is sidelobe suppression. This is the Windows bar. This is the original sequence of our process. The sequence is to be calculated. The peak sequence is to be calculated from the signal between the time and amplitude ratio. This is the peak sequence clipped from the original sequence is to be calculated from between the time and amplitude. The peak sequence is very useful to reduction the peak to average the power ratio. This is the clipped sequence from the original sequence. This is the remaining sequence from the after the clipping the original sequence to the peak sequence of our process between the time and amplitude. This is the error signals to be calculated between the input signal sequence and the clipped sequence. This is spectrum effect. It very helps to detect the sidelobe of our process. This is calculated using a high power amplifier. This is the blue color, is a red color waves to be passed, spectrums to be passed. It displays the effects is called before, between the after amplifier, the before amplifier, in between the spectrum units, and representing frequency in the x-axis and y-axis also. This method is used for the dynamically extension of constellation points of the signal. The munal constellation is to be represented. The yellow color is the extension of our munals, and the blue color is the before amplifier of our process to be between the I channel and the Q channel of our process. This is the AM by AM response of our power amplifier. In this process, we have to use the high power amplifier. We have to measure the mean of waveform amplitude in amplifier response and the linear response of our process. This is calculated from the input amplitude and output amplitude of our process. This point is represented as the mean value of waveform amplitude. This message bus is very important in this process to calculate the giant PAPR reduction, sidelobe suppression, to calculate the mean error rate, bit error rate, modulation technique, IFFT size, and required interval size and saturation level in decibel of our process, and then click OK. This is to be measured to the values of in decibel and points and modulation technique of our process. The next window we have to represent the many munals are sequence used in signal cancellation process. After the signal cancellation process of original signal is to be plotted from the normalized saturation level in decibel between the modulation error rate of our process. The modulation error rate values to be viewed in the previous message box. This is the comparison graph between the existing and the proposed system of our process. Now we have to conclude the process. In this process we have to using the signal cancellation, suboptimal signal cancellation method to extend the cancellation point dynamically, and then adding the signal cancellation symbols to the users to giant PAPR reduction and suppress the sidelobe of original sequence very effectively done. Thank you.